AB Calculus Note Card 67, Average Value of a Function. This is the 67th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who develops Note Card system. Average value of a function. If function f is integrable on the closed interval from a to b, its average value or mean value on the interval from a to b is, and there's a song for this, 1 over b minus a times the integral of the function integrated with the limits. That's the average value. So that's how we get our average value. And so we're going to examine how that is found. Now, up until this time in calculus, when we've talked about average, we've talked about average rate of change. Average rate of change is a concept related to differential calculus, whereas average value is related to integral calculus. And 1 over b minus a times the integral of a function, integral of this function, integrate it with these limits, and that's the average value. And so this total integral here over b minus a is like the area divided by the width of that function at c. So I'm going to make a little diagram to show what's going on here. We have a xy coordinate plane, and we have a function here, f of x, and we have a value a and a value b along the x-axis here, input values. And so we're looking at this total area here that I'm hashing in. Okay, that's the area that we're looking at. And there's a value c somewhere that's the average height of this shape here. And so it's like we have a big area. I'm going to label A for area, and we have at the bottom here would be like the width would be like b minus a, so that'd be like the width, and this average height here, okay, this will be the height. And so if this function, for instance, were velocity, we would be finding the average velocity, because if you have area equal width times height, height would be analogous to this. So we would take area divided by width. And if our width is b minus a, that is conceptually how we are considering this an average value application. And if we have, for instance, an average velocity, we want to find an average velocity, we have to take the integral of a velocity function to get that. So that's somewhat different from what we're looking at. So there are three specific problems we're going to be doing here. The first one, find the average value of y equals x squared times the square root of quantity x cubed plus 1 on the interval from 0 to 2. So we will call this value 0a and this value of x value of 2b. So our average value is going to be equal to 1 over b minus a, which is going to be 2, times the integral of the function, which is going to be x squared, times the square root of quantity x cubed plus 1 dx, integrated with the limits, and the limits from 0 to 2. That's the average value. And so we're going to have a U-substitution here. So we're going to let u equal this quantity x cubed plus 1. And du is going to be equal to 3x squared dx. And dividing by 3x squared, dx is going to be equal to du over 3x squared. And so we're going to make our substitutions here for u, for this guy right here. And we're going to substitute dx here and take it below. So we're going to be equal to 1/2 the integral, and I'm going to have x squared times, this is going to be the square root of this thing here is going to be u to the 1/2 power. And then we're going to have, replacing dx, we're going to have du over 3x squared. And x squared over x squared cancel each other. But there's one remaining item of business we need to take into account before we can continue, and that's to change these limits. So these limits here, right here, this is in terms of x, 0 in terms of x, 2 in terms of x. So we're going to say if x equals 0, u is equal to 0 cubed plus 1, which equals 1. So 1 is going to be our new lower limit. If x is equal to 2, u is equal to 2 cubed plus 1, which is going to be 9. So our upper limit is 9. So now we're going to, I'm just going to work below here, 1/2. And I'm going to bring this over 3 out front to be 1/3. And this u to the 1/2 becomes u to the 3/2. And we're going to divide by 3/2, which is the same as multiplying by 2/3. And we're going to evaluate between u equals 1 and u equals 9. Now let's clean this up some more yet. We have 1/2 times 1/3. I'm going to write up here 1/2 times 1/3 times 2/3. We're going to multiply all these numerators together. We get 2 over 2 times 3 times 3 is 18. So we're going to get 1/9. So we're equal to 1/9 u to the 3/2 evaluated from 1 to 9. And we're going to have, our integral is going to be f of b, big F of b, minus big F of a. This is going back to our fundamental theorem of calculus section. So we have 1/2. We're going to have 9 to the power of 3/2. And we're going to subtract out 1, I said 1/2. I meant to put 1/9. There we go, that looks better. Minus 1/9. We're going to have 1 to the 3/2. What that is going to be equal to is 1/9. We're going to have square root of 3 to the power of 3 over 2 is going to be the square root of 9 cubed minus 1/9 the square root of 1 cubed. And that's going to be equal to the square root of 9 is 3, and 3 cubed is 27. So we have 27 ninths, and we have the square root of 1 cubed is 1. So we're going to have minus 1 ninth. And so our answer is going to be 26 ninths. And that's going to be our average value. Next, problem 2. Find the average value of f of x equals sine x over the interval from 0 to pi. Well, again, we have 0 equals a and pi equals b. So our average value is going to be equal to 1 over b minus a, 1 over pi, times the integral of a function, which is sine x dx. And the limits are from 0 to pi, and that will be it once we figure that out. Now, from earlier in this course, we've talked about this method of figuring out what's going on. So if we're integrating, we're going in a counterclockwise direction. So the integral of sine is going to show up here as negative cosine. So we have 1 over pi times negative cosine x, and we're evaluating from 0 to pi. And working to the right, we get, we're just going to substitute in here 1 over pi, and again it's this big f of b minus big F of a, fundamental theorem of calculus. And what I'm going to do with this negative cosine here, I'm going to put this negative sign out front. Okay? And then we're going to have cosine of pi, all right, minus, parenthesizing, negative 1 over pi. We're going to have cosine of 0. And let's work below. So we have negative 1 over pi, and the cosine of pi is negative 1, and we're going to have minus negative 1 over pi, and the cosine of 0 is 1. So what we're going to have is negative 1 times negative 1 is going to be 1 over pi, and then we have minus negative 1 over pi, so we're going to have plus 1 over pi, and so our average value is going to simplify to 2 over pi. That's it. Okay, the last problem we have is a calculator problem. It's the same concept. We have A is going to be 0, and our B is going to be 40. So our average value is going to be equal to 1 over b minus a, or 1/40th, the integral of, instead of writing all this out, I'm going to call it f of t dt, and that's going to be, and we're integrating over the limits from 0 to 40 now. That's going to be it. So let's go to our calculator and plug this in. So what we have is, make sure that we are in radians. This is a trigonometric function we're integrating. So we're going to have 1/40th and it's going to be times the integral. Use the hotkey shift plus sign. We're going from 0 to 40, and we come over here to the right. I'm going to make parentheses. We have 6 plus the cosine of, we're going to put t over 10. I'm going to put t over 10 and come out here. We're going to say plus 3 sine, and we're going to have 7t over 40, and I think that's going to be it entirely, dt. Just checking, make sure things are right, and looks like they are. Okay. Press enter. We get 5.91627. And according to AP standards, we would go to 3 decimal places, so officially we call this 5.916, and that's going to be our average value of our function. So I hope this has been helpful to you. Good luck, and thanks for viewing.